All right, so like I said before, we're talking about quotients with radicals, so we're talking about division. So you're typically going to be seeing it set up in fraction form. So square root of 5 over 9. You can break these apart eventually, where you have square root of 5 over square root of 9. But when you're working with problems in fraction form, the first thing that you want to check to see is if your denominator of your fraction happens to be a perfect square root or a perfect square. So let's write that down, that the first thing that you're always going to do, you're going to first check if the denominator, which is the bottom part of your fraction, is a perfect square. Always the first thing that you want to be able to check. So you're going to split these up. You're going to break this fraction apart to where it's the square root of 5 over the square root of 9. And we want to see, is the square root of 9 a perfect square? Yes or no? Yes. Okay, this is a perfect square. Okay, so I'm going to then break this apart to where it's square root of 5, which is not a perfect square, over square root of 9, and I'm going to identify that it is a perfect square. So I'm going to put it in my pink. I know that doesn't show up very well as pink, but then I'm going to go ahead and solve it. Can I simplify square root of 5 at all? No, square root of 5 is as simplified as it can possibly get, so it's going to stay square root of 5. But what is the square root of 9 going to become? 3, and we no longer have the radical underneath. So there's no longer a square root underneath. Because here's the important thing. You are not allowed to have a square root in your denominator. It's not allowed. So when you are working problems out, you need to make sure that you simplify it so that there is no square root in the denominator. Eventually you're going to get to problems where even no matter how much you simplify it, it's always going to have a square root. And then I'll teach you how to rationalize the denominator. That's going to be tomorrow's unit, okay? But for today, we simplified it. We found our perfect square already for the denominator and simplified it out, and there's our final answer. Now, if you get to a problem like number 2, square root of 12 over square root of 27, again, our first step in a problem like this is to check if the denominator is perfect. That's the first thing that we want to do. We want to check to see if the denominator is perfect. Is this a perfect square? 27. No. 27 is not a perfect square. There is not a single number that you can multiply by itself to equal 27. So that's not a perfect square. When that situation happens, you would then move to step 2. You want to try to simplify the fraction. Meaning, I want to see if I can divide 12 and 27 by a common factor. So what are both 12 and 27 divisible by, Divya? 3. They're both divisible by 3. So I'm going to go ahead and do that first. I'm going to divide them both by 3. When I do that, that gives me the square root now of 4 over 9. Do I now have a perfect square for my denominator? Yes. So I'm going to go ahead and break these apart. This is the square root of 4 over the square root of 9. Is square root of 4 a perfect square or not? It is. Square root of 4 is a perfect square. Okay, so I'm going to go ahead and put that in pink. And then square root of 9, we already said is a perfect square, so I'm going to put that one in pink as well. What is the square root of 4? 2. And what is the square root of 9? 3. So there's our final answer, 2/3, with no square roots anymore. Okay, I want you guys to go ahead and do problems 3 and 4 Just problems 3 and 4. Do not do question 5 yet. Just problems 3 and 4. All right, so for problem number 3, we have square root of 80 over 25. First thing that we always check to see is if the square root of 25 is perfect. Is it perfect or not? It is, right? This happens to be a perfect square. So we can go ahead and break these apart. We know that square root of 80 is not perfect, so I'm going to go ahead and put that in green. But the square root of 25 is perfect, so I'm going to go ahead and put that into pink. Now, I'm not going to simplify yet because I'm going to take a look at square root of 80. Can I break square root of 80 up? Yeah, right? Square root of 80 can be broken apart. What is the largest perfect square that can go into 80? 16. Square root of 16 can go into 80. So I can break this up as square root of 16 and the square root of 5. Because 16 times 5 is 80, and square root of 16 is a perfect square. Square root of 5 is as simplified as it's going to get as a non-perfect square. Then I can put the whole thing over the square root of 25. Now I can go ahead and take my square roots of my perfect squares. What is the square root of 16? 4. So we have 4 square root of 5 over, what's the square root of 25? 5. Now one thing I want to check to see is if I can simplify this. Notice that I have the 4 and the 5 both in pink. So that when I try to see if I can simplify my fraction at all at the end, I'm only going to simplify a pink with a pink. I'm not going to simplify a pink and a green. Okay, because one of them is inside the radical and one of them is outside the radical. So you cannot simplify these 5s together because one's inside and one's not. So they're not really like. Okay, you would focus on 4 over 5. So if I hide this, can I simplify 4 over 5? No, I cannot simplify 4 over 5. So this is as finalized as my answer is going to get. Okay, let's take a look at problem 4. We have square root of 40 over the square root of 98. Is the square root of 98 a perfect square? Yes or no? No. 98 is not a perfect square. So what we want to do is we want to try to simplify. What can we divide them both by in order to create 98 into a perfect square? Maya? 2. They both can be divided by 2. They both can be divided by 2 because they are both even numbers. So when I do that, I'm going to get the square root of 20 over 49. Is 49 a perfect square? Yes. This is a perfect square. So now I can go ahead and break it apart. I'm going to say that this is the square root of 20 over the square root of 49. I'm going to put square root of 49 in pink because pink is perfect. Okay, now I'm going to focus on the square root of 20, which was not perfect. Can I break 20 up into a perfect square? Armando? 4 and what? 4 times 5. 4 is a perfect square, 5 is not. So I can do square root of 4, which is perfect, and I can do square root of 5, which is not perfect. 4 times 5 gives me 20. All of this is going to be over the square root of 49. Okay, now I can take my square roots. What's the square root of 4? 2. So we get 2 square root of 5 over, what's the square root of 49? 7. And there's our final answer. 2 square root of 5 over 7. Or 2 radical 5 over 7. Okay? Now let's take a look at problem number 5. The reason I didn't want you going to number 5 is because problem 5 has some variables involved. So I wanted to make sure that we did an example of it together before I release you onto your own. So we have square root of x to the 5th over 81x. In a situation like this, again, you want to identify if there happens to be a perfect square for the denominator. is the entire denominator a perfect square? So let's focus first on the number. Is 81 a perfect square? Yes. Is x a perfect square? No. So you want to split this apart in order to be able to simplify them. Notice we have x's on top and we have x's on the bottom. So basically what this looks like, guys, if you were to break this down, it kind of looks like x times x times x times x times x on the top, and then on the bottom it looks like 81 times x. Remember that if you have a value on top that's exactly the same as a value on the bottom, you can simplify them. You can take away one of these x's on the top to be able to remove the x on the bottom. Remember back when we were doing our exponent rules. X to the fifth over x is just going to equal x to the fourth. You subtract those exponents and keep the base. So now this becomes the square root of x to the fourth over the square root of 81. Is the denominator a perfect square now? Yes. The denominator is now a perfect square. So I'm going to put square root of 81 on the bottom. What about the numerator? Is the numerator perfect or not? It is. How do we know that the variable has a perfect square? Because it's even. Remember, this is an even numbered power. If it's an even numbered power, it is a perfect square. So we have x to the fourth inside of our square root as a perfect square. We can go ahead and simplify it. What is x to the fourth going to simplify to? X to the second. And what does 81 simplify to? 9. So we get x squared over 9. Okay, I want you to go ahead and try on the back. I want you to try problems 6 through 10 on your own. Try 6 through 10 on your own. All right, let's go ahead and go over these. So problem number 6, we have the square root of m to the third over 9m. Again, the 9 is perfect, but the m is not. So if we were to look at this as a broken down portion, this would be m times m times m on the top, and then we would have square root of 9m on the bottom. We could get rid of these single values of m's. And what we'd really be left with is the square root of m to the second power over the square root of 9. Both of these do happen to be perfect squares. Square root of m to the second power is perfect because it's an even exponent. Square root of 9 is perfect. So if we were to take the square root of both of them, you should have gotten m over 3 as your final answer. M over 3 for your final answer. Okay. For problem number 7, we have 4x to the second over 36x. Again, we have a single value of x on the bottom. We cannot have that single value of x on the bottom. So if we were to look at this, we could say it's 4 times x over 36 times x. These single values of x's here can be canceled out. And now we would be left with 4x on the top and 36 on the bottom. Is 4 a perfect square? Yes. Is x a perfect square? No. So we have square root of 4 and square root of x for the top. On the bottom, is 36 a perfect square? Yes. So we have square root of 36 on the bottom. So now we're going to go ahead and take these square roots. What is the square root of 4? 2. So we have 2 square root of x over, what's the square root of 36? 6. Here's the thing though, can we simplify 2 over 6? Yes. 2 and 6 are both divisible by what value? 2. They are both divisible by 2. So you need to be mindful that sometimes even after you take the square root, you might still be able to simplify. So when we take 2 and divide it by 2. That becomes a single value of 1. Do I have to put the 1? No, I don't have to. If I do, it's fine. I can put square root of x right behind it, or I could just say square root of x. And then 6 divided by 2 is going to become 3. So you can either write it as 1 square root of x over 3, or you could just write it as the square root of x over 3. Either one of those would be perfectly fine. Either one of these answer choices would be perfectly fine. Okay, let's take a look at problem number 8. We have square root of 20b to the 7th over 25b to the 3rd. Again, I have an odd exponent on the bottom. I don't like having those odd exponents, so if I were to break this down, it would become the square root of 20, and then we have b times b times b times b times b times b times b. All of those written out. I'm only doing this because some of you are still not being able to see how you can simplify with your exponents, but we know that technically we could just do 7 minus 3, right? We know we could do 7 minus 3, and that would give us b to the 4th. But here you have b times b times b. These are all going to be able to be canceled out. These 3 b's on top and 3 b's on bottom can go ahead and get canceled out. So then you're left with the square root of 20b to the 4th over the square root of 25. Let's identify our perfect squares. Is 20 a perfect square? No. 20 is not a perfect square, but can I break it up into a perfect square? What can I break 20 up as? 4 and 5. So square root of 4 and square root of 5. Is b to the 4th a perfect square? Yes. So I'm going to put square root of b to the 4th. That is a perfect square. Okay, is square root of 25 perfect square? Yes. Square root of 25 is a perfect square. So then when I take my square roots, I should get 2b to the 2nd, and then square root of 5 over 5. Can I simplify this any further? No. That's as final as it's going to get. Okay, number 9. Square root of 65x to the 5th over 125y to the 10th. X and y, those are different bases, so you cannot simplify them. But if I were to break these apart, so let's focus first on the square root of 65 over 125. Let's focus first on that. Is 125 a perfect square? No. It's a perfect cube, but it's not a perfect square. So we need to simplify that first. What are they both divisible by? 5. They end in 5, therefore they're both divisible by 5. And that's going to give us the square root of 13 over the square root of 25. Okay, now we do have a perfect square for the denominator. Now let's focus on our variables. Our variables, we have x to the 5th over y to the 10th. Is x to the 5th a perfect square? No. But can we break it up into a perfect square? Yeah, how do we break x to the 5th into a perfect square? You take 1 away. You just take 1 away. Okay, so we would have x to the 4th, and then x. What about y to the 10th? Is that a perfect square? Yes, because it's an even power, so we have square root of y to the 10th. Now let's focus on the numbers. Square root of 13, is that a perfect square? No, so that's just square root of 13. Is 25 a perfect square? Yes, that's square root of 25. Okay, so now if we piece all of this together, let's focus on the numerator first. The only perfect square we have for our numerator is x to the 4th. If we take the square root of x to the 4th, that becomes x to the 2nd. We still have square root of 13 and square root of x on the top, so we have square root of 13x on the top. On the bottom, we have two perfect squares. Square root of 25 is 5. and square root of y to the 10th becomes y to the 5th. And there's your final answer. For our last one, we have square root of 3x to the 3rd over 64x to the 2nd. 3x to the 3rd over 64x to the 2nd. X to the 2nd is a perfect square, but I'm going to have to simplify anyway. So I might as well, since it's variables, might as well just go ahead and simplify. X to the 3rd over x to the 2nd. If we break these all apart, so if I have x to the 3rd over x to the 2nd, what is that going to become, guys? X, right? It's just going to become x on the top. I'm going to keep a fraction. I can just subtract these. I can subtract a 2, subtract a 2. It gets rid of the x completely. And then when I subtract a 2 on the top, it gives me just a square root of x over 1. Okay, square root of 3 over square root of 64, that's still going to be broken down. Which one is that? A perfect square on the bottom? Yeah. So we have the square root of 64 on the bottom, square root of 3 on the top. And then here, this happens to be a perfect, or sorry, the 1 happens to be a perfect square, but the x is not a perfect square. So that becomes square root of x on the top, and that becomes a square root of 1 on the bottom. Okay, we have no perfect squares on the top, so we can just combine them together as 1. We have square root of 3x. What is the square root of 64? 8. And what is the square root of 1? 1. And what's 8 times 1? 8. So you get square root of 3x over 8. Be very careful, guys, because sometimes the biggest mistake that I see people make when they give their answer, if they have a square root on the top, they're always like, oh, square root of 3x, and then they put over 1, and it almost looks like it's still inside of the square root. You need to be very mindful that your square roots are designated to a numerator. Okay, if it looks like it's belonging to the denominator, it's going to get marked wrong. You do have an assignment. It is a worksheet, and what I did go ahead and do this time is I made boxes and grids for you to be able to show your work in. So let me go ahead and get that printed out. Those of you who are going the Jekyll trip, what I would like for you to do is when you finish your assignment, please upload it into Google Classroom. You can snap a picture with your phone of each of the pages and upload that into the Google Classroom and just hit turn in.